they talk about recursive over here. So first thing first is that you have this empty item. So obviously you pop back up empty. So now you have a 3 right now. So the next time is that you add the 3. And now you need to pop back up this whole entirety system, and this we got to introduce the 2. So we can either put it at the start and towards the end, and obviously you can see the 2 towards the start and towards the end. And now you got 1, 2, 3. You got to add the new 1 into all of this. So you're gonna be able to actually insert it, the start, the middle, and the end for all of these items. So as you can see, for maybe say the first set is that I'm gonna put the start at the start, the middle, and towards the end. And similarly for this second set, I'm going to put at the start, the middle, and towards the end. And in total, you can see all the permutation that's been calculated for this entirety thing for such. And whatever like this item of permutation may actually mean, like is this, that whatever is actually trying to do on this whole permutation thing is that no matter like if it's like, even if they contain like the similar like unique set, they are considered to be overall to be different. And there you can see that the number of like possibilities is a lot. So first thing first is that this set we're getting maybe say 1 item, and here we have like 2 items. And coming to here is that one item, this is sort of like 1 item, and from here it suddenly become 2, and from 2 it suddenly becomes 6. So it's like +1 and then +4. And I just feel that if you were to look in the graph settings, however fast these guys are producing, I feel like it's an exponential one. It's very, very quick. It's going very fast. And it's maybe say power of n. I don't know, like maybe this guy is like 2. And that's how I actually envision this whole problem to speed up exponentially in terms of like the number of like patterns it can take for at least permutation. And the spell that is actually casting is, it comes down to a lot to do with first and foremost like identify it as like being a permutation, which I think it falls under the category of like the character. So rather this is talking so much about the character. And whatever this guy is actually doing is like counting the max number of like combination, and it sort of like disregard the say the unique values at all. And that's why it falls under the category of a lot of like 2 power of n when you talk about like this item. And I mean for like the Leetcode rulebook, it talks a lot to do with I want just like disregarding like unique values. The moment you disregard unique values, it sort of like straight away instinctively tells you that it's kind of like a permutation already. This is the rulebook. And this spell, whatever it's doing, it's just like doing some form of like instinctive adding of like items. So what it does is that it adds middle, left and right throughout the entirety of things, and then you sort of like get back your value. And notice how the values always like come from the bottom, so it acts of like a form of like recursive function with the instinctive like adding. So it's like a combination of these two items that you recurse backwards, that you start all the way from the bottom and you just instinctively say that, okay, now I'm gonna introduce you with a 3. Okay, I'm gonna insert a 3. Oh, I'm introducing you a 2. I'm gonna start middle end. Each time you have like a new value, you just instinctively add it towards the start, middle and end. And you sort of like as it transfers throughout the tree, like sort of like a tree, you just keep on recursively adding of this instinctive adding functions. And I mean that obviously you always will have like some form of like brute force to actually fight against this main character. And I can tell you this, if you were to use the brute force method, you're gonna like add one by one. I think in terms of like brute force, however you want to add it, is that you're going to start off with say that, okay, I'm introduced with 1, 2 and 3, so maybe at the start I will have at start I'll have 1, and then every single combination of 1, so 1, 1, 2, 1, 3, 1, 2, 3, 1, 3, 2. I think brute force will be in sort of like, I don't know, my theoretical guess is for this one, at least it may be iterative. Right? And that's how I actually am gonna use the brute force to actually fight against permutation. Permutation, in terms of like code wise, I feel it will be very much more instinctive and much more simpler, because at the end of the day you are just using one function. The cool thing about this is that just one of this function, and you add entirety throughout. I don't know about like this whole iterative, maybe the coding will be much more complicated. The cool thing about this way of recursive solving is that you use one function, instinctively add recursive. That's the beauty about recursive, to be honest, because it just requires one function throughout the entirety of the same of the items. You do the same thing throughout the entirety as it transverse throughout the entire tree. That's what I believe, and I'm really very much curious of like finding out about this recursive versus the iterative, and I believe my next video is going to talk about it, because on the previous episodes I think that's what they are talking about, and I'm very curious to actually find out more about it. So yeah, everything comes to an end.